Our perceptions of our world and our universe are ever-changing. New knowledge and new understanding is the force driving reconsiderations of what was solid fact before a new discovery. We believe what we believed. The corner is turned and there it is, an epiphany. More than 400 years ago, the Earth was considered to be the center of the universe. Galileo made observations that clearly showed the Sun, not our Earth, was the center of the solar system. He was sharply criticized and subsequently jailed for his heresy against the Church. So, even though he stated the obvious and what is now considered fact, his concept of a solar system with the Sun at its center was viewed as obscene. Still today, we frequently reject alternate observations as absurd, regardless of merit, in favor of the understood. The Earth, Mars, Jupiter, Saturn, and beyond, our local group of planets and cosmic dust have long been perceived as a disk of spinning objects. This, however, is not the shape of our solar system. Our star, with its gravitationally held collection of spherical worlds and interstellar debris, travels through the Milky Way galaxy at extreme speed, dragging the cluster of planets in its wake like a corkscrew. This is your new perception of our star and its entourage. Your thoughts of our planets in the solar system are now altered. Not a disk of worlds, but a spinning spring of intergalactic speed and motion. Our Earth, some 5 billion years old, has followed our star in a path around the galaxy more than 20 times during that 5 billion years. We have passed through clouds of cosmic dust, rocks, and debris collecting material for what is now our world. Our planet is the land and the oceans. We hope for a constant. We want the Earth to remain the same size. This, of course, is impossible. Our planet must have started as a loose collection of rock, liquid, and gas, gaining size and mass as it traveled. Everything changes. We all went through school and studied various subjects such as math, science, and the written word. In the realm of the earth sciences, one of the concepts presented was the theory of continental drift. This theory proposes that the continents as they appear today began as one large landmass called Pangaea located on one side of the planet. Hundreds of years ago, cartographers, people who make maps, began to notice North and South America's coastlines strangely match with Europe and Africa across the Atlantic. Like a puzzle, these coincidences of shape gave rise to the proposal that the continents must be moving. The modern proposal for the continental drift theory was presented to the German Geological Society in 1912 by Alfred Wegener. He had originally proposed the concept of the Pangaea supercontinent. He had theorized the continents we know today were gathered together on one side of the planet. This was certainly a plausible concept given the lack of information concerning the ocean floor at the time. The Earth's continents were perceived to have begun as one huge landmass, splitting and separating along the center of the Atlantic. Alfred Wegener's original proposal from 1912 was a reasonable concept for the era, but was missing 3 pieces of information not available at the time: the ocean floor terrain map, the ocean floor age map, and the ocean floor sediment map. This information didn't exist until 50 years later. This observation, made by Western Europeans, follows not only the obvious coastlines of the Atlantic forming a clear puzzle, but it also coincided with what was at the time the most explored ocean in the world, the Atlantic. The Pacific, while we knew it existed, was not the predominant trade route of the time. The Atlantic was. However, in order for this continental drift theory to hold, the ocean floor would then, of course, need to be reabsorbed on the Pacific side of the Earth in a process referred to as subduction. 3 concepts must exist for this theory to hold. First, the Earth must remain the same size, the shorelines of the continents remain similar to what they are today, and the water levels would then remain constant. This is certainly a comfortable hypothesis and easy to explain. And for all this to work and keep the Earth the same size, you need subduction. At the time the continental drift theory was originally proposed, there was no such thing as sonar, so the ocean floor could not be mapped with any degree of accuracy. The earliest expedition to chart the depths of the ocean was the voyage of the HMS Challenger in 1873. In concert with a host of previously unheard-of scientific experiments, the Challenger, for the first time, took ocean floor depth measurements with a rope. In 1916, towards the end of World War I, a technological marvel was in its infancy: sonar. Sonar uses sound and time to calculate the distance between a ship and an object on the sea floor. During the wars, sonar was primarily used to locate submarines. It wasn't until after World War II that sonar technology was adapted to map the ocean floor. This began in the 1950s. And it wasn't until 1977 that the first ocean floor terrain map was introduced to the public. In addition to mapping the physical terrain, core samples were taken worldwide to begin to outline the age of the ocean floor as well. Here is where contradictions begin to surface. The Earth is estimated to be over 5 billion years old, but somehow the ocean floor, as it turns out, is a maximum of 300 million years old. The age of the ocean floor is only 5% of the age of the planet. Did the continents stay still for 4.8 billion years and then start to move? Apparently, they did. For the continental drift theory to make sense to the casual observer, the ocean floor would be more than 300 million years old in the Pacific and younger than 300 in the Atlantic, if the continents were in fact moving in that direction. The movement of the continents and the corresponding age of the ocean floor would look like this: diverging in the Atlantic and converging and subducting in the Pacific. Unfortunately, the ocean floor in the Pacific is actually expanding faster than it is in the Atlantic. The actual ocean floor age map looks like this. There are expansion zones worldwide. The age of the ocean floor, information gathered 50 years after the sliding continent concept was proposed, contradicts the theory of continental drift. These subduction zones are supposed to absorb the material from the expanding crust on the opposite side of the planet. This would stand to reason, of course, since if the new crust appeared on one side, it would have to be absorbed elsewhere. Otherwise, the planet would have to expand. On the coast of Seattle, for example, there is supposed to exist the Cascadia subduction zone. This area, which is prone to earthquakes, is supposed to be absorbing the ocean floor beneath the coast of Washington, proposed to move in this direction. However, the coastline of Seattle is clearly expanding, and the ocean floor age map shows the ocean floor moving in the opposite direction, stretching and splitting the crust, forming the Seattle, Puget Sound, and Vancouver Island in Canada. Then there are the pictures of rift or splitting and spreading zones. Lots of them. They are visible worldwide. The largest obvious rift zone on the planet is at the bottom of the Atlantic Ocean, which runs halfway around the globe. In its northernmost reaches, it splits the country of Iceland into pieces. In the south, it reaches Antarctica. There are the Mediterranean and East African rift zones. You can see the spreading patterning all over the planet. North of Canada, the islands above the Arctic Circle fit together like a puzzle. And there are, of course, pictures of this phenomenon. Hundreds, if not thousands, of images of cracking and spreading of the Earth's crust. Then, the opposite of this spreading and expansion on the other side of the planet, surrounding the Pacific Ocean, are the proposed subduction zones. Judging from this map of these apparent collision areas, there are supposed to be in the neighborhood of 40,000 miles of subduction zones. However, for some reason, there are no photographs of this phenomenon. This geologic activity has apparently been occurring for more than 250 million years, over 40,000 miles of coastline surrounding the Pacific Ocean, and somehow we don't have one photograph, just drawings and animations. The Pacific Ocean sediment layer is an average of 750 feet deep. This sediment is comprised of all manner of decomposing material collected over millions of years. The distance from the coast of South America to the center of expansion in the Pacific is approximately 2,400 miles. The ocean floor age map shows this sub-oceanic crust has been expanding towards the west coast of South America for approximately 50 million years. If we consider a 1-mile stretch of coastline subducting under the continent over 2,400 miles for 50 million years, the coastline would be advancing at approximately 3 inches per year. Let's consider for a moment that only 10% of the ocean floor sediment was scraped off as the ocean floor subducted under the continent. This 10% would be a 75-foot deep by 1 mile long slab of sediment left behind as the ocean floor advanced. As the ocean floor made its way under the continental crust, this would leave behind over 77 million cubic yards of sediment up against the continent per mile of advancing ocean floor. Over these 50 million years and 2,400 miles, that would equal 185 billion cubic yards of material packed up against South America per mile of coastline. The resulting mountain of sediment would be over 22,000 feet deep. That's a lot of mud. We would imagine the ocean floor sediment map would look like this: relatively thin in the Atlantic and thicker in the Pacific next to the subduction zones. However, the actual ocean floor sediment thicknesses are opposite of what you would imagine. The sediment is over 20,000 feet thick in the Atlantic and comparatively non-existent in the Pacific. If the ocean floor is subducting under the North and South American continents, why haven't mountains of sediment been left behind? Did it all just disappear? The glue that holds the continental drift theory together is the subduction zone. Without subduction, you have an Earth that is growing, expanding in all aspects, with the continents as we know them today rising from the depths of the ocean as the planet grows in size. Let's try this again. Suspend in your mind the subduction zone concept for a few minutes. In all cases worldwide, we see clear evidence of expansion. The middle of the Atlantic, the Pacific, Indian, and Southern Oceans, the Mediterranean Sea, and even the shorelines of the Red Sea, the Icelandic rift zones, and the Rift Valley in Eastern Africa. In North America, expansion of the Great Lakes, the islands north of Canada and Hudson Bay, the Gulf of St. Lawrence, as well as the west coast of North America from Seattle to the Baja Peninsula in Mexico. Our current consensus concerning movement of the continents looks something like this. The oceans stay the same level, the shorelines are similar, and of course, the Earth stays the same size. Imagine our Earth was 1/3 the size it is now, some 350 to 400 million years ago. Using the National Oceanographic and Atmospheric Administration data documenting the age of the ocean floor and the age of the continental crust, watch as the Earth expands in size and the continents drift apart as time advances. Beginning with the Atlantic, the coastline of South America will move away from the west coast of Africa, and the east coast of North America splits with Europe. The newest ocean floor, first shown in blue, then green, then red, creates the Atlantic Ocean floor as we travel forward in time. 180 million years, 120 million years, 50 million years in the past. The rift zone that splits the Atlantic and brought about this ocean occurred over the course of 250 million years, creating a gigantic puzzle framed by deep continental shelves. And now the Pacific. The vast Pacific Ocean today covers almost half of the planet. 350 million years ago, Australia was the keystone. With the Earth 1/3 the size, the continent of Australia filled the space between Antarctica to the south, the Alaskan Peninsula to the north, Japan and China to the west, and North America to the east. As the Pacific Ocean floor expands at 3 times the speed of the Atlantic, watch as Australia breaks away from North America, leaving Indonesia and the Philippines far out to sea. The size of the Pacific Ocean today makes it difficult to visualize the continental puzzle pieces surrounding the Pacific once fit together in the same fashion as did the Atlantic. Like a jigsaw from the beginning of time, all the continental plates reconnect on all sides of the planet, on a much smaller planet. Let's add water, lots of it. We live on a mostly water-covered planet. The world's oceans currently cover over 70% of the Earth's surface. Beginning in the present day, we will travel back in time. As the continents move together, the land disappears below the surface of the ocean. As we travel back over millennia, the water begins to flood the Amazon basin, submerging the continent of North America, beginning in what is now Texas and Florida, then moving north to Canada. The oceans will finally submerge the continent of Africa, ultimately creating a world dominated entirely by water. This would offer an explanation of why we find fossils of ancient ocean floor creatures high in the mountains worldwide. Once again, as the planet diminishes in size, the continents converge, and as they do, in almost biblical fashion, they sink below the surface of the ocean, finally arriving at an entirely water-covered world some 350 to 400 million years ago. One may wonder where the extra material comes from to account for the increase in the diameter of the Earth. I suppose you could also ask where the extra material comes from when a loaf of bread increases in volume as it bakes, since the bread expands to 3 times the size as the dough that was originally slid into the oven. Consider water. This is one of the only compounds that expands when it freezes. It expands approximately 8 to 10% in volume when it is frozen than when it is a liquid. The crushing force of this transformation is so powerful it can split automobile engines in half and crack rocks from mountains. The center of our Earth is predominantly iron. By itself, it exists in the universe as one of the primary building blocks of asteroids and, as luck would have it, our planet. The core of the Earth, as well as the crust, are almost 35% iron. As iron absorbs oxygen, it becomes iron oxide. More specifically, rust. Rust is larger by volume than elemental iron. A lot larger. When iron becomes iron oxide, it expands to 8 times its original volume. Another strange thing happens when iron oxidizes. It increases its mass by almost 10%. This oxidizing process is so destructive that ships will tear themselves apart as the iron hulls reabsorb oxygen and expand to 8 times their original dimensions as they transform. The expansion question? Where's the expansion occurring? In the core. Our Earth is expanding. It is possible our Earth is rusting from the inside as water from the surface migrates through fissures created by the receding continents. The water from the surface contacts the elemental iron in the depths of the core and converts the fundamental iron core to iron oxide. And this process expands the Earth as the core transforms from intergalactic iron to rust.
Number 1. The electromagnetic energy coming from the sun. The electromagnetic energy / current from the sun interacts with the inner solid core to create the electromagnetic induction effect, the magnetosphere, and the spin force, also known as the homopolar generator effect, in conjunction with the moon. This causes friction between the inner solid core and outer solid mantle or crust, and is a factor in creating the lava region. Number 2. The constant supply of the building blocks of matter. Atomic matter is composed of subatomic matter, also known as the ether / dark matter, etc. The subatomic energy, the ether, dark matter, or subatomic matter, coming in through the poles from outer space into the inner core and into the inner Earth layers. The molten lava region is constantly supplied by the subatomic building blocks of matter. The ether/dark matter/subatomic matter keeps the lava region increasing in volume and expanding by generating more molten mass. This supply of energy keeps the lava region in constant mass volume growth. This constant growth of the lava region mass causes an outward push force of expansion on the crust/mantle of the planet. These are the main factors for Earth's continuous growth and continental expansion. Earth, and possibly other planets, is like an organism in constant growth, always increasing in size due to the following three factors. 1. The electric or electromagnetic currents, radiation heat, and energy from the sun. 2. The unlimited supply of the subatomic building blocks of matter, ether, dark matter, subatomic matter from outer space. 3. Constant motion/movement of all celestial bodies throughout the universe. These three forces are the building blocks of life in the universe.
We arrive again at our planet 540 million years ago, the beginning of the Cambrian period and the dawn of life. Our Earth was 1/3 the diameter it is today, blanketed by the sea. The fossils found at this time were all undersea creatures dominated by the trilobites. These crustaceans ruled their watery world for 250 million years. The trilobite is a very distant relative of the pillbug. These aren't actually bugs, they're also crustaceans. They are both arthropods and they both have gills. Once you consider that prehistoric fossils from the Cambrian period prior to the age of the seafloor spreading are of sea creatures like the trilobites that are all found on what is now the land. If the continents were all gathered together in one landmass 500 million years ago, then how did the ocean floor animals like the trilobite get here? The second group of creatures of interest and thought to be the first to venture onto dry land came into existence approximately 350 million years ago. This is the crossover point. These were the tetrapods, or four-legged creatures. The expanding Earth concept creates an environment suited for the evolution of the tetrapods. Lizards, horses, bears, dogs, cats, bats, birds, and even humans belong to this group. If you imagine the Earth expanding, the dry land began to appear from beneath the water-covered planet 350 million years ago, corresponding almost exactly with the appearance of the tetrapods. The group that is the tetrapods is the link between the sea and the land. Combining the timelines of ocean floor expansion, receding water levels, and fossil records, the eruption of the continents from beneath the sea corresponds with the evolution of land animals. As the Earth expanded, the continents rose from the depths of the ocean and exposed the dry land. The new continents created shorelines and new habitats as they appeared. Our primitive Earth began to expand, the waters receded, and created the Pacific, Atlantic, and Indian Oceans. The prehistoric life that walked onto the continents did not wait 250 million years to venture onto the dry land. They moved from the sea to the land when the environment became available. They didn't hold out under the sea and randomly decide 250 million years later to crawl onto the beach and through the swamps. They didn't venture onto the land because the land wasn't there. Our universe has expanded from the beginning of time until the present moment. And so too is our Earth moving and expanding, as do all things. Consider your own perception. Origins of life, the birth of our universe. Time and the beginning of all things. Then you find a change. an epiphany, a new discovery. What you thought you knew is forever modified, replaced with an understanding grander than before.